Hi, I'm Kai. Now I'm going to do the question 2 of homework 4 for the probability and stochastic processes. So question 2, the random variable x is uniform in the interval -1, 1. We need to find g of x such that if y is equal to g of x, and then the density function of y is y to the power of -y times u of y. So at first, we know the x is uniform in the interval of -1 and 1, so we can write down the distribution function and the density function of x. And the distribution function is and it will be 0 when x is less than -1, and it will be x plus 1 divided by 2 when x is between -1 and 1, and it will be 1 when x is greater than 1. And the density function of x is 1/2 when x is between -1 and 1, and it will be 0 otherwise. And then we want to calculate the distribution function of y. So the density function of y is given. So from this function, we know that if y is less than 0, and the density function will be 0. And if y is larger than or equal to 0, we know that the distribution function would be the integral from -infinity to y, fy of t dt. And this one can rewrite as the integral of from 0 to y e to the power of -t dt, and the final result will be 1 minus e to the power of -y. And then we have the distribution function of y. We know in the inverse problem we can use the capital Y of gx is equal to the capital Fx of x. So when x is between -1 and 1, we know this one is the x plus 1 divided by 2. So the left side would be 1 minus e to the power of g of x. And then we moved the 1 to the right, and then we take log on the both sides, and then we can get the gx is equal to minus ln of negative x minus 1 divided by 2. So this is the g of x when x is between -1 and 1. And then if x is less than -1, the left side is the same and the right side will be 0. And then we can calculate that the gx will be 0. And then when x is greater than 1, the left side will be the same, the right side will be 1, and then we can calculate the gx will be infinity.